Now for the continuation of 5.2. So here we have the basic probability rules. So rules that a valid probability model must obey is if all outcomes in the sample space are equally likely, the probability of an event is the number of outcomes in the event divided by the possible number of outcomes in the sample space. Also, the probability of any event has to be between 0 and 1. All possible outcomes together must have probabilities that add up to 1. And the probability that an event does not occur is 1 minus the probability that the event does occur. So this is known as the complement rule. Complement is denoted by this C in the exponent location. So what this is saying is the probability of not event A. That's another way of writing it. If we're looking for the probability that A does not occur, so that's the same thing as saying 1 minus the probability that A does occur, because all the probabilities added together will be 1. The complement rule is usually forgotten by many, but is actually very helpful. Sometimes it's easier to count what you don't want and subtract it from 1 than it is to count what you do want. So if we roll 2 fair dice, what is the probability that the sum is 6? So again, like we did before, you're looking for all the outcomes, the sum is a 6. 5, 1, 4, 2, 3, 3, and the reverse of the first 2. So there's a total of 5 outcomes out of the 36. So if we roll 2 fair dice, what is the probability that the sum is 5 or 6? Well, we're going to add them together. 4 over 36 plus 5 over 36. A total of 9 out of the 36 possible outcomes, or 0.25 as a combined probability. So two events, A and B, are mutually exclusive if they have no outcomes in common, and so they can never occur together. So can the sum of the dice be a 5 and the sum of the dice be a 6 simultaneously? No. So these events are mutually exclusive. So the probability of A and B, the probability of getting a 5 and a 6, is 0. So in order to find the probability of 5 or 6, you have the addition rule for mutually exclusive events that says the probability of A or B is equal to the probability of A plus the probability of B. Reminder that this only works for mutually exclusive events. If we were looking for the sum being 6 and one of the dice being a 2, well, those are not mutually exclusive because 2, 4 or 4, 2 happens both as a sum of 6 and one of the dice is a 2. So this rule wouldn't work in that situation. They must be mutually exclusive. So kind of just in some symbolic notation, some of those probability rules. For any event A, the probability is between 0 and 1, inclusive. If S is the sample space, the probability of all of it is 1, because it's all the possible outcomes. In the case of equally likely outcomes, we have the number of favorable outcomes divided by the total number in the sample space. We have our complement rule, and now we have our addition rule for mutually exclusive events. So here's a problem. Suppose you tear open the corner of a bag of M&M's milk chocolate candies. Pour one candy into your hand and observe the color. According to Mars Incorporated, the maker of M&M's, the probability model for a bag from its Cleveland factory is... Explain why this is a valid probability model. So looking down here at the answer, these are the probabilities of each of the colors. Orange, yellow, red, brown, blue, and green. When you add the probability of each of them, it becomes 1. All the probabilities are a positive number between 0 and 1, and the sum of all of them equals 1. So B says, find the probability that you don't get a blue M&M. the probability of not a blue, well, it's easier to count what the probability of blue is and then subtract it from 1. So the information that should have been provided above is that 0.27 was the probability of a blue M&M. So instead of adding all of these other probabilities together, we could simply take 1 and subtract the blue, what we don't want. So 1 minus 0.207 gives us 0.793. So part C, what's the probability that you get an orange or a brown M&M? So we have to think, when I get one M&M out of the bag, can it be orange and brown? No, these two cannot happen simultaneously, therefore they are mutually exclusive. So that allows us to simply find the probability of an orange M&M, the probability of a brown M&M, and add them together.